All right, let's take a look at number 34. Again, we're going to be running into a problem because we're taking the square root. So we do not want this to be a negative number. It's okay to take the square root of 0. So what we say is that this guy, the argument 16 minus x squared, has to be bigger than or equal to 0. So if I add x squared to both sides, or I flip it, this is telling me x squared has to be less than or equal to 16. Now we got to figure out what values of x satisfies that constraint. Well, if we take a look at, alright, so if we ask the question, what values of x when I squared am I less than or equal to 16? Well, obviously I can't pick x to be 10, right? Because 10 squared is 100, that's definitely not less than or equal to 16. So I just started asking silly questions like, well, can I use 0? Yeah, 0 squared is 0, which is less than or equal to 16. Can I use 3? 9 is less than or equal to 16. What about 4? 4 squared is in fact equal to 16, right? So this is, you're not going to put in a 5 here, that's not going to be less than or equal to 16. And we can also go in the negative direction, can't we? So if I take a negative 3 and I square it, that's 9. That's still less than or equal to 16. And if I use a negative 4, that is 16 is less than or equal to 16. But if I try to use negative 5, no. 25 is not less than or equal to 16. Which means I'm allowed to choose x's between negative 4 and 4. And notice that I colored these in, I filled those dots in. So in other words, we are only allowed to look at x's in the interval minus 4 to 4. And in this situation, we can use the what? The negative 4 and the 4. Otherwise, if we try to take outside of that interval, we're going to get ourselves taking the square root of a negative number, which means we have complex numbers. All right, let's take a look at this. Kind of awkward. Let's take a look at the next thing. So now, when I take a derivative, I've got to rewrite this as what? The square root is a 1/2. So this is a power rule and chain rule. So the 1/2 is going to come down. You're going to subtract the 1, but then you have to take the derivative of the stuff that's what inside. Derivative of 16 is 0. Derivative of x squared is going to be the minus 2x, just what I've got here. And so what's going to happen is the 2's are going to cancel. I'm left with a negative and an x on top. Okay? Now, so my derivative is this guy. Now, notice we're going to run into a problem. Critical points occur when what? The function, the derivative is 0, or when the function is not defined, in which case you don't want to be taking a square root of 0. So this is telling me one possibility is that this fraction is equal to 0. And when is a fraction equal to 0? Only if the numerator is equal to 0, right? So if we put in a 0 here, let's just check. Square root of 16, not a problem. 0, that is equal to 0. So we have one critical point is at x equals 0. Next type of critical point. The derivative is a critical point is when the denominator is what? 0 possibility. Which means, if you think about that, that's a plus or minus 4. So we have several critical points. We have the one where it's at the derivative is equal to 0, and then we have the others that are so if I take and ask when is the denominator equal to 0, that's what I'm doing here. So I could say that's really 0 square when I square both sides. That means x squared is equal to 16, which means there's two critical points where the derivative is undefined, plus or minus 4. So in other words, we have critical points also at 4 and negative 4. And we also had the critical point where we set the numerator equal. So I actually have something, 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 correct? But what did we say in terms of restricting the domain? We had to, where was it at? Does everybody remember this? We're only allowed to look at the function or its derivative in this interval, which means I'm not allowed to look here or here. And in fact, because we could have been dividing by 0 at x equals 4, negative 4, we're not allowed to look at here and here, which means we're only allowed excuse me, to look at these two regions. So let's pick a nice test point in region 1. So between 0 and negative 4, I'm going to pick negative 1. And again, folks, all I care about, don't waste your time evaluating what that is. Just ask yourself the question, is this number positive or negative? So put in a negative 1, negative 1. Negative, negative is positive. The denominator is positive, so this has to be positive, which means it's increasing. Next, suppose I look in this region right here. I'm going to pick the nicest number I know of between 0 and 4, which is 1. Put it in. Top is negative, bottom is negative, so this becomes negative, which means it is decreasing. So this is telling me in region 1 it's increasing, and in region 2 it is decreasing. It looks like this is going to be a relative max. Okay, number 60. Here's my derivative. Here's my function. I gotta find my derivative. Now notice there's no restrictions on to be on the axis. I can cube a number, square a number, multiply by negative 3, add on a 5, not a problem. So just take a derivative. The 3 is going to come down, 3 becomes a 2. 3 times 2 is 6, and the derivative of this is 0. Now, we're going to be setting this equal to 0. Oh, by the way, there's no restrictions on the x's, right? You can pick whatever you want. So I want to set this equal to 0. Please don't use this form. Factor it. Notice I could take an x and a 3. I'll go ahead and do that. So the reason for doing this now is when I try to find the critical points, I'm going to set this equal to 0. 3 is not 0, so we know immediately x has to be 0 or x has to be 2. So we know we have 2 critical points. We'll put those down. So we have a critical point at 0 or at 2. 0, 2. Which means I have 3 regions. So I've got to pick a nice number in region 1. How about negative 1? Nice number between 0 and 2. How about 1? Nice number to the right of 2. How about 3? Alright, so if we take negative 1, please don't put it in this form. Put it in the factored form. Okay? So if I put in a negative 1, I get 3, which is a positive number, negative 1 minus 2. Please don't tell me what this whole number is. Positive, negative, negative, which means it's positive, so that means it has to be increasing. If I choose the nicest number between 0 and 2, like 1, just substitute it into your first derivative. Please do not put it in expanded form. Put it in the factored form. 3 is a positive number. The test point is 1, so I'm going to put in a 1, and what happens, this is a negative number, it means it is decreasing. Region 3. I'm picking a number to the right of 2. How about 3? That's all I've done here. Positive, positive. 3 minus 2 is positive. It's positive. It means increasing, decreasing, increasing. So it looks like 0 is a local max because it looks like it's coming up this way. 0 cubed. So if I take, let's see, x equals there. Okay. Now, if I want to know what this max is, I put in the critical point 0 into not the first derivative, but the original function, because I want to find out what this height is. So if I put in a 0, this is the original function, I get a 5. So in other words, we have a local max at x equals 0, and the y is equal to 5. So it's up there. How do I find the local min? In other words, what is this minimum value? So I have a critical point at 2, put it into the original, not the derivative. Now you have to tell me what that number is. And this number turns out to be, so we get 2 cubed is 8, minus 12 plus 5, which is 1. So we now have a local minimum at x equals 2, and that minimum value is equal to 1.